Hello everyone. In this chapter we're going to focus on the information that was presented in Chapter 5, Section 5.2, solving equations for the unknown and then proving your answer or proving the solution. Now I will tell you that the problems in the way that they're set up in the textbook are assuming that you've had some form of algebra prior to actually looking at this. However, I want to assure you, if you have not to worry. We can always make arrangements to meet. I'll be happy to help you to work through some of this because there's a lot of content in this particular chapter that if your algebra skills are kind of weak or it's been a long time since you've done it, you might need some additional practice and work, and that's what I'm here for, is to be able to help you. So I am going to do this presentation as though I'm just brushing you up. If you need some more intensive help, I have some additional resources that you can look at, as well as please be sure to contact me. I'll be happy to help you through any type of problem that you may have as we work through solving some of these different types of equations. So let's go ahead and take a look at our first one here. We have x plus 4 equals 15. Some of the things that I start out by telling people is basically one of the cardinal rules that you need to remember: letters on one side, numbers on the other, okay? And I'm referring to the equal sign, of course. So if we take a look at this, we need to get rid of this 4 so that our variable can stand on its own. How do you do that? Well, what you have to do is you have to do the inverse or opposite operation that it talks about in your textbook. And to make this 4 more or less be removed from this side of the equation, we do the opposite operation. If that's addition, we know the opposite subtraction. So I'm going to go ahead and I'm going to subtract 4 from here. However, one of the things that you need to keep in mind is that whenever we do the inverse operation, it cancels. But what we do to one side of an equation, we always have to do the other side. So because I subtracted 4 here, I'm going to go ahead and I'm going to subtract 4 from there. What does that do? That leaves me with the x by itself, the equal sign, and we go ahead and we subtract 15 from 4, and we're going to get 11 as our solution. Now we need to prove it. How do we know it works? Well, we go in and we substitute 11 where the x is. So we get 11 plus 4 equals 15. 11 plus 4 is 15. 15 equals 15. So we know we solved that. So that is when we're dealing with an addition problem. What happens when it's subtraction? The steps that you follow remain the same. So if I look here, we have h minus 20 equals 44. So let's go ahead. We're going to go ahead, do the inverse operation. We want to get rid of that minus 20 if we're subtracting. We know the inverse operation is to add, so we're going to add 20 here. But again, what we do to one side of the equation, we have to do to the other. So we end up with h equals 44 plus 20 makes 64. So we plug that in. 64 minus 20 does indeed give you 44. So you know your answer is correct. So now we've got to look at our multiplication. So we've done addition, subtraction. What happens when we're multiplying? Well, what's the opposite of multiplication? If you remember, it's division. So basically what we have to do is we have this problem set up, 9t. We may read it 9t equals 36, but what the problem is saying is 9 times some number is going to give us 36. Figure out what that number is. Because it's a multiplication problem, we need to divide. So what we do to one side, again, we have to do to the other. We already know, because we've done fractions, that 9 divided by 9 is a 1. And when we write equations, we don't include the 1 in front of the variable, we just write the variable. So instead of having 1t, we just have t here. And if you remember, It's looking like a fraction, but I told you once you started with this course, we didn't think of this as a fraction line, we think of it as a division line. So we know that 9 goes into 9 goes into 36 4 times. So then we get a solution of 4. We plug it in to make sure we're right. 9 times 4 equals 36, and indeed it does. So the t is becoming the 4. We substitute it, and again, number bumped up against the letter indicates multiplication all the time. So sometimes people, let's move on to what a division problem is. Sometimes with division, people get a little confused because it looks like a fraction, but again, we're not thinking of it so much as a fraction, we're thinking of it as a division problem. So we are having m fifths equal 4. What's the opposite operation of division? It's multiplication. What do you multiply by? You're going to multiply by the denominator. So we're going to multiply by 5, and we're just going to put our 1 there to make it a little bit neater, okay? So then when we go ahead and we do our cross multiplication, we're left with our 1m, which basically we just write as m, but we multiply by 5 on this side. So because we multiply by 5 on this side, we're going to have to multiply by 5 here. So we get 4 times 5, which is 20. So then let's plug it in. 20 divided by 5 is indeed 4. So we're just, again, doing opposite operations right now. These are what we refer to as one-step equations. We just needed to do more or less one step to solve it. Now we're moving into what we refer to as two-step equations. With two-step equations, you're going to have to do 2 different steps in the process. So let's take a look at this one. Remember, we always start out when we look at an equation, we want numbers on one side, letters on the other. So the first thing that we're going to go ahead and do is let's get rid of this 5. How do we get rid of the minus 5? We add 5. So if we add 5 to one side, we're going to add 5 over here. This cancels out, and what we end up with is 7r equals 56. Okay? Once again, now this problem looks like number 3 here. So what do we need to do? Because this is multiplication, we're going to go ahead and divide. We divide by 7 here, we divide by 7 here, and we end up with r equals 8. And then we could, again, plug it in, do the math, and I can assure you you're going to come up with 51. Let's look at some other problems. Once again, we're back here. We are dealing with x over 2 plus 20 equals 34. We want to get rid of the plus 20, and we know to do that, because it's a plus 20, we have to subtract. So let's go ahead, we're going to do our subtraction on both sides. That's going to cancel out. We get our x over 2 equals 34 minus 20 gives us 14. Okay? But again, we're still not done. This problem now looks like number 4. So we're going to go ahead and we're going to multiply our 2 times 1. When we do that, these cancel, giving us the 1x, or just x, but because we multiplied on one side, we have to remember to multiply on the other. So we end up with x equals 28. And again, if you plug that 28 into the x and finish the problem, you're going to end up with 34. Let's look at this one here. This brings in our order of operations. And your book kind of talks a little bit about order of operations, but if you need some more assistance with that, let me know. But I will tell you that when you see parentheses, basically, a number against parentheses means you multiply everything inside the parentheses. So that's what we're going to go ahead and do. We get 16K minus 8 times 4 is 32 equals 48. So basically what we did was we did our multiplication to be able to move our terms so we can get numbers on the one side, letters on another side. So to make this work, we're going to go ahead and add 32 and add 32 here. So when we do that, we're going to cancel that out. We get 16K equals 80. So then we go ahead and we divide by 16, and we're going to go ahead and we are going to come up with, I didn't do the calculator, so I didn't write the answer down. You have to pardon me if I don't have the calculator with me. Let me look real quick, because it's in here. Come from your textbook. Okay, we have our 16 divided by 80 equals 5. And yes, even math teachers sometimes have to look up the answer because they don't do that level of division right off the top of their head. So, bear with me. Okay, let's look at the last one here. We're going to go ahead, and what we need to do here in this section is what we call combining like terms. So we put all the letters together, we put all the numbers together. But again, it's going to be a couple steps to do this. So as we look at this, I want you to notice we have a 4C here minus C. If you remember, I always told you that a 1 is indicated as being there. So what we're saying is, what is 4C minus 1C? Actually, that's going to give us 3C. Plus 7 equals 25 minus 6C. So, as we're looking at this, I know that there's a 6C here. We're going to figure out how to do that. But right now, we've got a 7 over here. And we're going to go ahead, let's get rid of this 7. So we have just the 3C over here. So how do we do that? We go ahead and we do the opposite side. And we're going to subtract 7. So we subtract 7 from both sides. That cancels. We get 3C equals 25 minus 7, which is 18. But then we have a minus 6C. It's the first time where we have saw a letter on both sides. How do you do with that? The same way you dealt with numbers. We want to get rid of it. How do we get rid of it? This is a minus 6C. Go ahead, we're going to add 6C. To that side, what we do to one side, we have to do to the other. So when we go ahead and we subtract that, and that cancels out, we get 9C equals 18. We go ahead, we divide by 9, and our answer is C equals 2. So if we plugged in everywhere there was a C, the number 2, we would come up with an answer that is equal. So this highlights all the types of problems that's presented in Chapter 5, Section 5.2, Solving Equations. But again, if you're kind of confused by this or you have additional questions, please be sure to contact me. I'll be more than happy to go over any of this in more detail with you.